Hello and welcome to G Fun Facts Online. What if I told you that some of the most high-stakes secrets in the world aren't uncovered by spies, but by analyzing a single speck of dust? Today, we're diving into the incredible field of nuclear archaeology, where scientists become atomic detectives to unlock the history of nuclear programs and help keep our world safe. So, what is nuclear archaeology? Imagine a crime scene, but instead of dusting for fingerprints, you're searching for isotopes. When a nuclear reactor is running or a weapon is built, it releases a unique cocktail of microscopic radioactive particles. These particles are like an atomic fingerprint, a silent whisper on the wind that tells a story a nation might not want to share. By collecting and analyzing these faint traces from soil, water, air, or even the walls of a building, scientists can reconstruct a complete history of nuclear activity. One of the most powerful tools these atomic detectives use is environmental sampling. Inspectors from global organizations like the International Atomic Energy Agency, or IAEA, can take a simple cotton swipe from a surface inside a facility. Back in the lab, a super-sensitive machine called a mass spectrometer can analyze that dust and determine not only if nuclear material is present, but also its type, like plutonium or highly enriched uranium, its age, and the processes it went through. This allows inspectors to check if a country's story about its nuclear program matches the physical evidence. But the clues aren't just in the dust. Scientists can also analyze the structural materials of a decommissioned reactor. The graphite blocks or steel vessels inside a reactor's core absorb radiation over its entire lifetime, creating a permanent operational record. By measuring the ratios of certain isotopes within these materials, they can calculate the total amount of plutonium that was ever produced in that reactor, a critical piece of information for verifying disarmament claims. Even trees can be witnesses. The science of dendrochronology, or studying tree rings, can reveal a historical record of nuclear events. Trees absorb elements from the environment, and atmospheric nuclear tests from decades ago left detectable traces of isotopes like strontium-90 in their annual growth rings, providing a dated timeline of past activity. This work is part of a massive global effort. The IAEA is at the forefront, using nuclear archaeology as part of its mission to verify that nuclear material is only used for peaceful purposes. Another organization, the Comprehensive Nuclear Test Ban Treaty Organization, runs a global network of sensors that constantly sniff the air for radioactive particles, listening for any sign of a secret nuclear explosion anywhere on Earth. It's like a planetary-scale security system, and this science has been proven in the real world. When South Africa voluntarily dismantled its nuclear weapons program in the early 1990s, nuclear archaeology was crucial in confirming that their declaration was complete and all weapons were accounted for. It was a landmark success for disarmament. Contrast that with Iraq in the 1990s, where IAEA inspectors used environmental sampling to uncover a vast, secret nuclear weapons program that had been hidden from the world. The lessons learned there made global inspections much more robust. Looking to the future, nuclear archaeology is seen as an essential tool for any potential denuclearization of a country like North Korea. Verifying the history of their complex program would be a monumental task, and the ability to analyze samples from their reactors and waste sites will be absolutely essential for building international confidence in any agreement. The field is also constantly evolving. Scientists are integrating artificial intelligence to analyze complex data more effectively, and are developing portable devices that can give inspectors results on site in minutes instead of weeks. In a world where the threat of nuclear proliferation is still very real, nuclear archaeology provides a powerful, science-based path to building trust and transparency. By listening to the faint, lingering whispers of the atom, we can better understand our past and work together to build a more secure future for everyone.